Okay, in the previous video we showed what it means to be in steady state, and we showed that steady state means that the current going in through the small area is equal to the current going out through the big area. How could you rewrite this in terms of the current density? We know that the current is J times area, so I1 is J1A1 and I2 is J2A2. So that means that if the area here is small, then the J1 has to be large for the product to stay the same, because the area here is large, so the J is small. So the J for the larger area is smaller than the J for the smaller area. So the J is not the same through both at both surfaces. How about the electric field? Well, the electric field, we know that J is sigma E, so we can write J1 as sigma E1 and J2 is sigma E2, and the sigmas are the same. The conductivity, the material is the same, so we can cancel the sigmas. We get E1A1 is equal to E2A2, and so that means also for the small area the electric field E1 is large. For the large area the electric field E2 is small, because the product has to stay always the same. And how can we then write this in terms of the drift speed? We know that J is equal to what in terms of the drift speed? J is equal to NQV. So J1 is NQV1 and J2 is NQV2, and the N is the same. Remember, we said that the charges cannot be compressed. The number of charges per unit volume stays the same. Charge Q is the same, so NQ can be cancelled. We get this result that V1A1 is equal to V2A2. So when the area is small, the velocity vector is large. When the area is large, the velocity vector is small. So the velocity is smaller when the area is large. And so this is a summary of all the conditions of steady state. This is the case for the current, this is the case for the current density, electric field, and speed. Now this also gives an idea why when they write down on a wire, why do they write down always the value of the current? Why don't they write down the value of the current density? This may give an idea why it's more convenient to write down the value of the current, because if you have a situation like this where the wire changes its radius, the current is always the same. So if you write down the current here, say 5 amperes, here it will be 5 amperes too. But if you write down J to describe the amount of current in a wire, J is not the same at different locations if the area changes. So this is one reason why the current is the preferred number to label on wires.